graphs, functions, and systems of equations in this particular chapter. So we're going to start with 8.3 and not 8.2. No, I'm sorry, we're starting with 8.2, not 8.1. 8.2, we're talking about lines, slopes, and average rate of change. So the first thing I want to talk about is linear equations in two variables. Try to laugh now. Come on, guys. And basically, this is a linear equation in two variables. A, B, and C are going to be any real numbers. A and B cannot be zero together. One can be zero, but not the other one. Then it would be a linear equation. Okay. Both can't be zero. Both of them be zero. It's not linear at that time. So if one of them is zero, it's fine, but both of them can't be zero. And this is what we call a linear equation. This format right here is called standard form. It's called standard form. Because x is to the first power, that's a linear equation, which means that graph of that equation will be a straight line. Okay? We talked about quadratics. Quadratics, that means x is to raise to what power?
The second.
Second power. What kind of graph would that make? A U-shaped graph, which we talked about in the last chapter. Okay? Any questions on that part? Now, there are three ways that you can graph. Alright, when you're graphing. First way you can graph is called a table of values, which is an X and Y table. It could be an input-output table. Input means X, output means Y. Okay? Now, say that they're asking you to graph. And they give you this table here. That's the table of values. And ask your graph using the table of values, which is that gave you those particular values. One thing I would do is just plug in for these particular values given. So they said x is 0. You plug it in. What you're doing is 2 times 0 plus y equals 4. That's going to give you 0, so y is going to equal to 4. So when x is 0, y is 4. So that means your ordered pair is going to be 0, 4. Now remember, these are linear equations, so they're going to go in this coordinate plane. This is a coordinate plane right here, with the x-axis here and the y-axis here. The x-axis, just like the number line, everything starting right here is the origin. Everything to the right is positive. 1, 2, 3, 4. Everything to the left is negative. -1, -2, -3, -4. That's the x values. Your y values going to go up and down. That means everything up will be positive. 1, 2, 3, 4. Negative is going to go down. -2, -3, and -4. Okay? And what we have are quadrants. This is quadrant 1. That's quad 2. That's quad 3. That's quad 4. And you're going to have ordered pairs. Ordered pairs are the points that's going to be located in this plane. And they're in parentheses like this. And it's x comma y. You name x first and then y. So that means this ordered pair, when x is 0, it is 4 for this linear equation here. Turn around, I'm going to do it, then I have y. Y is 0. So I'm going to put in 0 for y and solve for x. So then I divide by 2, and x is 2. So x is 2 here, so my quarter point would be 2, 0. Do the same thing for 2. Let 2 be y, so I'll put 2 here, which means at that point I'm going to have to subtract 2. That's going to equal to 2. And then divide by 2, and x is equal to 1. So again, that's 1, 2. And then I'm going to have that x equals -1. So now I'm going to let x equals -1 here. What that's going to give me is a -2 plus y equals 4. And add 2. So now y is 6. So y is 6 here. And my quarter point is -1, 6. Now I can graph.
Is there any reason you alternated between x and y?
No, they were the points that were given. They only gave me, I think for the first one they gave me 0. Second one they gave me 0 for y. The third one they gave me 2 for y. They didn't give me the x. Okay. So now I'm ready to graph. So on my graph, I'll make an x and y plane. They have to be even intervals if I'm going to do it by hand. And I'm going to provide you with graph paper later, not right now. So I start here, I'm going to graph 0, 4. That means I start in the middle at the origin. X is not going anywhere because x is 0. But 4 is for y, so I go up 4. 1, 2, 3, 4, I'm here. 2, 0. Go back to my origin. I'm going to go 2, 0, so that means I'm actually going to go over 2 and not going anywhere for y. So it's right here on my x-axis. 1, 2, start back at the origin. I go over 1 because it's positive x, 1. Up 2 because 2 is positive, so 1, 2, I'm here. If you see, they're falling in a straight line. -1, 6, that means go up over to the left 1 and then up 6. 1, 2, 3, 4, 5, 6. So they all fell in a straight line. At that point, I find me a straight edge like a ruler or something. I'm going to do this and connect my dots. So when I do it, I take my straight edge. And then I'm going to connect my dots. When I connect my dots, alright, so then I'm going to do straight line, and you see that they fall in a straight line, which is collinear, and I put 2 arrows on each end. I have to put arrows on each end because they're continuous functions. They do not end. Okay, they're not line segments. Any questions on that? Let's do another one. Sometimes they're not going to give you any x and y's. So let me ask you to graph. Let's say 3x plus y equals 2. All right, they ask you to graph using a table. So I'm going to actually solve my equation for y first. It's easy for me to solve for y because what I'm going to do is pick 3 values for x. When I say use a table of values, I tell my students to always give 3 dots. Because of the fact that 2 dots do make a straight line, we know that. But because if you jack up your arithmetic and you make a mistake, you're not going to find your mistake. Most likely if you use 3 dots, you will not make you'll see if you made a mistake or not. So therefore, you can say, okay, if it doesn't fall in a straight line, if you make a triangle, then I know I'm messed up somewhere, and I go back and look at my arithmetic. And most of the time, it's just arithmetic errors that you made. So what we're going to do here is solve for y first, which gives me y equals -3x plus 2. The next thing I'm going to do is pick any 3 values for x. Three values for x. Don't care what they are. So I say 0, 1, and -1. At that point, since I solve for y is easier now, all I do is plug them in there for x and it's going to automatically give me y. That's why you want to go ahead and solve for y. Because if you don't, then what you're going to do is keep solving for y every time. So if I plug 0 in there, I get 0 plus 2 is 2. Plug 1 in there, I get negative 3 plus 2 is a negative 1. That gives me a positive 3 plus 2 is 5. Now I'm ready to graph. 0, 2 here, 1, 2, I'm here. 1, negative 1, over 1, down 1, I'm here. And then I have negative 1, 5, over to the left 1, and up 5. 1, 2, 3, 4, 5, I'm here. And they're falling in a straight line. So then I take my straight edge, extend my line, put 2 arrows on each end. Any questions? No? Alright. That's one way of graphing. And that's using a what? Table. That's using a table. Okay. Now we're going to do another way. The other way we're going to do, we don't use for graphing too much. I don't like using it for graphing because it only gives you 2 coordinate points. It's the x and y intercepts. We do use it for other things, and but I don't like using it for graphing. But it does help you to graph at times when you have to graph certain functions. But still got to understand what they are. So 1 is the table of values. 2 is your x and y intercept. First I got to define what my x-intercept means. What's the x-intercept? Anybody know?
Where the x crosses the...
Not the x.
Where the point crosses, where the arrow will cross on the x.
Where the graph crosses the what?
X-axis.
It's where the graph crosses the x-axis. Where the graph crosses the x-axis. If I don't know anything about this coordinate point, I know one thing. What is it? Y is always equal to 0. Y is always equal to 0. If I don't know anything about my x-intercept, I know one thing. I know that y is always equal to 0. So if somebody gave me a table, I don't care what they say. They gave me a table and it says 0, 5. Right there, just by looking at that table, I know this is my x-intercept because y is 0 by definition. On this graph, I know that this coordinate point, whatever this coordinate point is right here, this is my x-intercept because it crosses the x-axis at that point. Okay? Y-intercept. What is it?
Is where the graph crosses the y-axis, and x
Where
is always.
The graph crosses. And what do I know about that?
X is always equal to 0.
X is always equal to 0. They are 2 coordinate points, which means I'm going to have somebody for x here, but y will always be 0. I have x equals 0 there, and some value for y there. Okay, they are a coordinate point. Okay, but it's only 2 coordinate points. And we like to use them for other things. That's why on the last test when we were doing, when we had the book, when you throwing the book up and hit the water, okay, and it was a quadratic. Remember I told you it's actually finding zeros, and it's actually talking about the x-intercept because if you so high up on a story or a building, all right, this is the ground right here, which is x, and you up here, and you actually, it says something about that the book hit the water here, okay, which means it hit the water there, and this is talking about time, and this is talking about the height. Well, if you threw that book down and it hit the water there, what you're looking for, and they wanted to know how long does it take for that book to hit the water. How long? This is time. When you threw it up in the air all the way till it hit the water, you want to know how long. That means you had to set that quadratic equation equal to 0. And at that point, we were looking for, what's that? It's the x-intercept, where it hits that pool, which is the ground or whatever. And at that point, you had to solve that. And that is the x-intercept you were looking for. So, I want to find the x and y intercepts for 5x plus 10y equals 20. You must clearly identify which one you're talking about, because people get confused. All they know is somebody got to be 0, so they know which one I'm going to be 0, so off the other one, but they can tell me which one is which. Alright, you got to clearly tell me this. So, let's start with the x-intercept. The x-intercept. We know y is going to equal to 0. So I'm going to plug in 0 for y. So I have 5x plus 10 times 0 equals 20. Now I'm going to solve for y. So I'm going to get for x. I'm going to get 5x equals 20. And then I'm going to divide by 5. And x is 4. So my x-intercept is going to be 4, 0. That's my x-intercept. Now let's talk about the y-intercept. Look at it, Pete. I just drew a line. So now I'm talking about the y-intercept. X is going to be 0. So now I'm clearly identifying that this was my x-intercept up here. Now I'm doing my y-intercept. X is equal to 0. I'm going to plug in 0 for x. So 5 times 0 plus 10y equals 20. Gives me 10y equals 20. Divide by 10 because it's a linear equation, and y is going to equal to 2. So my x-intercept is 0, 2. Y-intercept is 0, 2. Yes. Any questions? So we got two ways of graphing. One is what? Second one is?
X and Y intercepts.
X and Y intercepts. Okay. I don't like using X and Y intercepts for graphing. It helps me to graph at times when I need it, but I don't really like just using that only to graph. Okay. Any questions on that? All right. Now, let's talk about the third way of graphing. It's called slope, intercept, point. This is the most important way. This is what we use all the time for graphing, basically. And that is y equals mx plus b. That's that one there. Y equals mx plus b. We use that way all the time. Okay? Y equals mx plus b. Now, when you use slope-intercept form to graph, I got to understand some things. To make sure it's in slope-intercept form, that means they solve for y. It's a linear equation which is x to the first power, and whenever they solve for y, it is in slope-intercept form. Now, slope-intercept form gives you two things. One, it's going to give you the slope. That's what this is, that m. This is called the slope. Let's talk about the slope for a minute. The slope tells you how steep a line is, so let's talk about the steepness of a line. That's what the slope does. It tells you how steep that line is. Okay? Now, we're understanding now that the slope have other names, other words and stuff that means. So what we understand is talk about the steepness of a line. It's represented as m. M is the slope. It is the change of y over the change of x. It is rise over run. It is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's the formula. It is the rate of change. All of this information that we just talked about is actually going to talk about the slope. Triangle means difference. So that's where that minus come in at, because it's saying a change of y's. So they're talking about the difference in the y's, and then the difference in the x's, where the change of x's are. So you can see somebody ask you to say m, they're letting you know m is the slope. Change in y or change in x, same thing, slope. Rise over run is slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1 is slope. And in our application problem, they may say find the rate of change, or what was the rate of change of over some time, or something like that. That means they're talking about slope as well. Any questions on that? Now, when you talk about your slope on a graph, your slope can look 4 different ways on a graph. One, and we read a graph the same way we read a book. We ain't make anything up. We read it from left to right. So we started here and went over, it went up. So that means the slope is positive. So basically we're saying this. For a slope to be positive, your graph should be leaning to the right. If I start here and go over, it went down. So that means that your slope is negative. So anytime your slope is negative, your graph should be leaning to the left. Now we have two special graphs, two special ones, that you're going to have to understand and have to know. Okay? One is the slope of 0. 0 is a horizontal. I don't huff and puff when I go straight across. Okay? When you're going up the stairs, I don't want to do that. Okay? That means they're going up, like going up the hill. You know, you don't mind going down. Okay? When you're riding a bicycle, sled, or something like that. So that's negative. But when you want to cross, that means that it has, the slope is 0. Okay? It's not that it has, it's not no slope, the slope is 0. 0 is a real number. So the slope is 0 here. Now, for this one, the equation is special. The equation would be always y equals a number. Y equals some number. Whenever you have y equals some number, that means that the equation, that graph of that equation is a horizontal line. So what they're saying is, no matter what x is, y is always that number. So if they ask you to graph y equals 2, using a table or something, and they say using a table, what I understand is this. In my table, I can pick any values for x. Y is always what? 2. 2. So when I graph it, 1, 2, it's a straight line on 2. Y equals 2 at best. And y equals 2 is here, so it goes straight across. 0, 2 here. 1, 2. 1 and up 2, that's there. 2, 2. Go over 2 and up 2. That's there. It's on that straight line. It's a horizontal line on 2. Y equals any number is a horizontal line on whatever that number is. And the slope is what?
0.
0. Okay? The slope is 0. And let me ask you, do it have an x-intercept there?
No.
No. That graph never crosses the x-axis. Okay? So the x-intercept is none. Okay? X-intercept is none. So here we know that the slope is who? 0. The x-intercept is who?
0.
None. We don't have one. The x-intercept, it never crosses the x-axis. Okay, so it's none. How about the y-intercept?
Y-intercept is 2.
It's 2. The y-intercept is going to be 0, 2. It crosses the y-axis. This is the y-axis. That graph crosses right here at this point, and that point is 0, 2. So it's not necessarily that point have to have an x or y-intercept. Okay? And then you got to pay attention about the slope if the slope is 0. Any questions? This last one, this is special as well. That slope is undefined, and it goes just like this. It's a vertical line. It's like that drop zone, I think, at Busch Gardens or something. I don't ride that. To me, it's not funny. Okay? You know, the Lotus Monster go down, and all of those stuff go like this, like that. That's fine. But the drop zone to me don't make any sense. Can't gonna go back up and go like that. You're not getting me on that. It's undefined. Undefined. It don't have a slope, and I ain't getting on it. Straight up and down. It's undefined. That variable, that equation is special. It is x equals a number. So whenever it says x equals a number, that graph goes straight up and down on whatever that x number is. Say that we got x equals -1. And they say use a table of values. What am I understanding? X is always who?
-1.
No matter what y is. X is always who?
-1.
-1. So that means when I graph that, here's negative x is -1. It's a vertical line on x equals -1. -1, 0 here. -1, 1, that's here. -1, 2, that's there. So it's a straight line, vertical line at x equals -1. And the slope of that line is who? What is it? Undefined. Undefined. Do I have an x-intercept?
Yes, -1.
At -1. So that point would be -1, comma 0. Because remember, x intercept, y is 0. How about a y intercept?
No.
Doesn't have one. So this is none. Because it does not cross the y-axis. So those are your two special graphs. You got to make sure that you remember those at all times. Okay? Any questions on that part? All right. Now we're going to work on finding the slope for a minute. Finding the slope given two coordinate points, and then we're going to work on graph and use the slope intercept formula. Find the slope of a line passing through 3, 5 and -2, 1. So that's me to find the slope passing through 3, 5 and -2, 1. So they want me to find the slope. They gave me two coordinate points. What am I using? Not slope intercept. Slope intercept is for graphing.
You're using the rate of change.
I'm using this formula here. This is a formula I can use to find the slope, given two coordinate points. Okay. And what this tells me is this. These numbers here tell me which coordinate point I'm talking about and what piece of the coordinate point I'm talking about. Second coordinate point for the y variable. First coordinate point for the y variable. Second coordinate point for the x variable. First coordinate point for the x variable. So I want to find out the slope of this line. So this is my first point, so I make that x1. This is y1. This is my second coordinate point. This is x2. This is y2. So I'm ready to plug in. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to plug in. Y sub 2 is 1. So I have 1 minus
5.
Y sub 1, which is 5. Over x sub 2, which is -2. Minus x sub 1, which is who?
3.
3. Then I have to do the order operation to the numerator. 1 minus 5 is -4 over -5, which the slope is 4 for this.
Hold on. How you get a positive?
Because a negative and negative is a positive. Dividing sign numbers. When you divide sign numbers, negative and negative is a positive, a negative and a positive is a negative. Same sign, positive. Multiplying and dividing sign numbers. Remember that? -2 times 3.
It's going to be a positive?
Negative.
Okay, so when we doing any problem, we're going to come up with, like, so -4 over -5 is not the final answer. You're going to have to
simplify that. That's this.
Okay.
Yes.
What if it's one negative number?
It's just negative. Alright. Let's say that I want to find the slope passing through 3, 8, 7, 9. No, 7, 8. Okay. This is x1. This is y1. x2, y2. So m is going to equal 2. And I'll write it here. We have 8 minus 8. 8 minus 8 over 7 minus 2. 3. 8 minus 8 is who?
0.
And 7 minus 3 is who? And 0 over 4 is who? It's 0. It's 0.
The first answer that was 4 over 5, will we write that 4, 5?
No, that's not an ordered pair. It's the slope of that line.
You gotta find the slope.
No, that's not an ordered pair.
Okay.
This is a slope. The slope is just telling you basically, and I explain, it's telling you how steep that line is.
Okay.
Telling you how steep that line is. So now, and what I'm understanding if it's 4 over 5, when I graph those 2 points that were given, my graph should be leaning to the right because it's positive 4/5. So it should be going this way, not that way.
Is that when we? Is that
okay,
when?
what was the point I had? I had 3, 5, right?
Right. And negative 2, 1.
And negative 2, 1. When I graph those, 1, 2, 3, 1, 2, 3, 4, 5. 3, 5 is here. Negative 2, 1, negative 2, 1 is here. See how I graphed those?
Right.
That lets me know my slope was positive. This slope was 4 over 5. So I ought to be leaning this way because it's positive.
Okay.
My slope let me know which way my graph should be leaning.
Okay.
And since this is a positive slope, okay, at that point it's going to be leaning to the right. When we do this one right here, the slope is 0. So if I was to plot those 2 points right there, when I plot those 2 points, 1, 2, 3, 4, 5, 6, 7, 8, that's 1. The other one is 7, 8, which means I go over 7 and 8 there. It goes straight across. But we knew that because the slope is who?
0.
0. Okay? Which I already understood by definition because both of my y's are the same. That equation is y equals 8. Remember I said that. If the slope is 0, the equation is y equals a number. Okay? That's me know. It kind of relates. This is the other thing, and this is what we're going to get into now when we're talking about graphing. What it is and what the slope help you do too, it helps you get to the next point that's on that graph from any point. So I can take a point, and the point if I might be like here at this point here, which is actually negative 2, 1. Well, this slope right here will get me to the next point that's on that graph. So what it's telling me is I have, since it's positive, I go up 4 units, and I count going up. And this is 1, 2, 3, 4. So I went up 4 units. 1, 2, 3, 4. And then I go over 5 units. And I think it was negative 2, right? So I go 5 units. 1, 2, 3, 4, 5. And it brings me right here.
Yeah,
that's basically what it tells
yeah, that's
you.
what I was
It'll
asking.
take you to the next point on your graph. Okay? So it takes you to the next point on your graph. That's what the slope does. It tells you how steep your line is. And also, too, it tells you the direction your line should be going. Whether it should be leaning left, right, flat, or undefined. So it can give you a lot of information. Yeah.
So, to keep it straight, I guess, 0 over x equals 0, and y over 0 would equal 5.
0 over a number is 0. That's what you mean. 0 over a number, any number.
Well, whatever, well, x would be the number that it is.
X, right, any number. 0 over any number is 0. Okay? The denominator can't never be 0. If the denominator is 0, it's undefined, which means that graph looks like that. Now you got it? If 0 is in the denominator, it's undefined. Even if you put it in your calculator, you come up with an error. And that means that this is undefined. Can't graph it on a number line system.
So when the 0 is in the numerator, it's just 0.
It's 0. 0 is a real number. 0 is a what? Is it an integer? Yes. Is it a whole number? Yes. Is it a rational? Yes. Is it a real number? Yes. So 0 is a number. It's found on the number line system. Okay. Now let's graph using slope-intercept form. First of all, before we graph using slope-intercept form, what I want you to do is to write each equation in slope-intercept form for me. And then after you write each equation in slope-intercept form, I want you to identify the m and the b. That brings me to another point. How do we know what m is if we put it in slope-intercept form? To write in slope-intercept form, it had to be solved for y, right? Everybody got that part? How do we know what part is m then? M is always attached to who?
Yeah.
X. It's the coefficient, okay, of that x value. That's my slope. This piece right here, which is b, is called my y-intercept. So my slope-intercept form gives me 2 things. It gives me my m and it also gives me my y-intercept. It tells me where that graph should be crossing the y-axis. That's what my y-intercept is, isn't it?
Yes.
Okay. So now you're going to solve each one for for y, and then give me the m and the b.